I just don't like I don't like having them in for me. Like, makes me feel like I'm in my head. All right, proving a quadrilateral is a parallelogram. Oh my goodness. All right, devices away, pay attention. Here we go. The beauty of 6-3 is it is the converses and maybe one extra from 6-2, okay? So it's really just reiterating in the other direction. And we're just going to list them again, but I'm going to draw pictures of each one of them for you just to make sure you're clear on what everything is. So we're going to space them out a little bit, but we are going to make a list, okay? Here's how we're going to start our statements. We'll say a quadrilateral is a parallelogram if ... Okay, so this is the if portion, but we're writing it reverse of that. Does that make sense to you? Yes. This is the hypothesis that I'm giving you, okay? So if both pairs of opposite sides of a quadrilateral are congruent, okay, is our first one. So number one, a quadrilateral is a parallelogram if both pairs of opposite sides are congruent. Okay, so in other words, if I have this picture and these are marked congruent, okay, it's a parallelogram. So they don't need to tell me it's a parallelogram. They need to mark opposite sides congruent, and I can say it's a parallelogram. Okay, so that's the first one. If both pairs of opposite sides are congruent, then the quadrilateral will be a parallelogram for certain. Okay, number one. Number two, a quadrilateral is a parallelogram if an angle of a quadrilateral is supplementary we'll just add that, is supplementary to both consecutive angles. What is consecutive again? Next to, the ones next to it. Okay, so if I were to draw you a picture of this one, it would look something like this. As long as I know in a quadrilateral that if this is 120, this one next to it here is supplementary, so 60. And the one next to it, put those away, Thomas, over here would also be supplementary. Okay, so as long as these two are supplementary and these two are supplementary, that has to be a parallelogram. Okay? So that's the second one. Third one, a quadrilateral is a parallelogram if both pairs of opposite angles are congruent. Okay, so for this one, if they give you this picture and they tell you those are the same and those are the same, you can say that must be a parallelogram. Okay, if opposite angles on both of them, can't just be one, both pairs of opposites are congruent, then it has to be a parallelogram. So far, so good? Okay, fourth one. There's 5. A quadrilateral is a parallelogram if the diagonals of the quadrilateral bisect each other. So that's the one we did today, right? In 6.2b. So for that one, as long as you can see this setup, and these are marked congruent, and these are marked congruent, okay? If I know those diagonals bisect, then I know it's a parallelogram. Questions on that? Okay, last one. And then we'll do a few examples. Yeah. Okay. Yes, that's what we did today. That's what I said like 30 seconds ago. Yeah. Welcome. Okay, last one of our list here says a quadrilateral is a parallelogram if one pair, and this one's new, you haven't seen this one, one pair of opposite sides is both parallel and congruent. Okay, so for this one, you'll have a parallelogram. All you need to know is that one pair of sides is parallel and that same pair of sides is congruent. Okay, it can't be that one pair is parallel and the other one's congruent. That doesn't work because that could be a trapezoid. But if the same pair of sides are both parallel and congruent, then that has to be a parallelogram. Okay, so those are the 5 things that you're going to be looking at. I'm going to give you just a few examples of how they're going to ask questions of this stuff, and then we will be done. Any questions on those 5, first of all? Are we good with that? Okay, first example. They will ask, and here's the difference. You're doing the same stuff that you did yesterday. They're asking it differently, but really a lot of it you're doing the same way, okay? So here's the question. They're going to say, for what value of x must RSTU be a parallelogram? Okay, and then they'll give you a picture, something like this, where this is R, U, T, and S. This side is 4y minus 3. RU is x plus 8. UT is 2y plus 5. And this is 5y. Okay, so the question is, for what value of x must this be a parallelogram? Well, if this is going to be a parallelogram, what do you know about it? Opposite sides are congruent, right? This would be using the one that says opposite sides are congruent. So that means these have to be the same, and that means these have to be the same, right? So they're asking for the value of x. Where do we start? We do know that x plus 8 equals 5y, but we can't solve that right now. If you look at these guys, these are both using y. So we're going to solve for y, and then we're going to plug that in here, and then solve for x. Okay? So we're going to start with 4y minus 3 equals 2y plus 5. So solving that, take away your 2y. You get 2y, add your 3. 2y equals 8, divide by 2, so y is 4, okay? So if I plug that in here, that makes the length of this side 20. Well, this side over here is also 20, right? So we can say then x plus 8 has to equal 20, and then you'll just take away that 8. So x would have to be 12 for this figure to be a parallelogram. Okay, so just like we did yesterday, you're still setting opposite sides equal. It's just that now they're asking the question, how do you make it a parallelogram? Well, by setting them equal, okay? Questions on that? Okay. Second type of questions you're going to see are these. Example 2. Not right now. Can you prove it's a parallelogram? Okay, and then tell me how. What theorem can you use? So I'm going to give you 4 different pictures here. Let's say in this first one, your picture is A, B, C, D. And where they meet in the middle here is E. Okay, if I tell you this is 14, this is 14, can you tell that's a 4?
Yes.
Sorry, that's kind of messy. And I tell you AE. Oh, no, just kidding. I wrote that in. I tell you DB is 2 times DE. Okay, so you're given this information, and you're given 14 and 14. Can you tell me right now that that's a parallelogram?
Yes.
Why?
No. Because they were.
Oh, yeah, because if, no wait, no, wait. Yeah.
No, you don't.
No? Because if the whole thing is
Because
double
bisect.
one, then
Right.
it
They
is
both
zero.
bisect
Okay.
each other.
So if DB is double DE,
Then that means AC.
whatever this is has to be the same as this, right? So DE and EB have to be the same if one is double the other, okay? These two are marked the same because they're both 14. So is it a parallelogram?
Yeah.
Yes. Why?
The
Number.
bisect-
Diagonals
diagonal.
bisect each other.
Number 4.
Okay? So tell me yes or no and tell me why. That's your first one. Second one. Let's say we have this picture. This is X, W, Z, Y. And I tell you the measure of angle Y is 49. The measure of angle Z is 131. And the measure of angle W is 49. Is that a parallelogram? They're supplementary on both sides, right? So if Z is 131 and W is
That's 118.
49 and Y is 49, as long as both sides are supplementary, which 131 plus 49 is 180, right? So as long as that's true, then it would be a parallelogram. So you would say yes, because both angles are supplementary to Z. Okay? Questions on that one? It's getting really warm in here, huh? Or is that just me? No, I turned it as low as it would go. All right, how about this? A little fancier here. If this is 50, and this is 130, and this is 5 and 5, does that have to be a parallelogram?
No.
It's not.
Why?
We don't know. We don't know it, but we don't know if it is.
Yeah.
No, we do.
Any eye. Why?
But
Impress me, Thomas.
Two of the angles add up to 180. That
So
means
what?
The other two angles are what?
no.
The other two angles are going to add up to 180.
We don't know that, don't you?
Yeah, we do, because
Well, it's 360, so it'd have to be 180 and 180. Doesn't mean they're the same measures. But they would add up to 180. Does that help you?
I'm confused.
Well.
Does this help you? What? Because that's how I always did it in chapter 3. What kind of angles are those? Supplementary. What's another name for those two types? Same side interiors. What do you know about same side interiors?
Oh.
That when they're supplementary, the
Triangles are congruent.
lines are
Parallel.
parallel, right? So because these are supplementary and same side interiors here, that makes these parallel. Do you know that's a parallelogram?
Yeah.
Why?
The line
Because
and
the-
the lines are congruent.
Yeah.
They're congruent. One pair of lines is congruent and parallel, right? So this would actually be yes. Even though it didn't look identical to any of the pictures I drew for you, you could say because of those two angles being same side interiors that the lines are parallel, right? So we would say yes because one pair of sides is congruent and parallel. Tricky, huh? Gotta pay attention. All right, last one of these. Parallelogram?
Yes.
Yeah.
Why?
No, because they're not opposites.
Consecutive sides are congruent, but not opposite sides are congruent, right? Anyone know what that would actually be?
Well, trapezoid would be.
You'll learn about it in chapter.
Trapezoid.
Oh, later in this chapter? Not a trapezoid, no.
It's like a diamond.
This is actually
No, it's like
called a kite when it's consecutives. So this would be no because it's not opposite sides.
Look, this should be the new slide.
I tried. You didn't try.
Okay? Questions on that? Okay, tell me this. This is not really, you don't need to write this down. Say you have a table. Have you ever seen those tables where you have like kind of a hinged table? And this is, so you can like lay it down or you can stand it up or like it'll go flat and you could like tuck it underneath something, but then you can hinge it up and it will,
The one side.
yeah, sometimes tray tables will do that.
Oh,
My question is, okay, you have this table tray, okay, we'll call it the tray table because that's what people have seen. So if you pull it out and you put it over your lap, is that top always going to be parallel to the ground? Is this 10 always going to be parallel
Yeah,
to this one?
yeah.
Why?
Because the
That's how they made it.
fives are the same.
Because opposite sides are congruent, right? If both pairs of opposite sides are congruent, this congruent to that, this congruent to that, this is a what? Parallelogram. And a parallelogram will always be parallel to its opposite side. So even if it shifts over, it's still going to stay parallel. Okay? If you would like extra visual, page 849 in your book has a chart of all of this stuff. It's just like a concept summary, but it just it has pictures of all the different things we were talking about. So if you would like to see that chart and look a little deeper, 849 is where you will go. But that's our lesson. Questions?